I think if you haven't built a system from scratch all the way through before and then had to worry about the security, the resiliency, the observability, and dealing with the failures and all of that pain that it entails, you think it's an easy task when it's not in any way.
This is DevOps Paradox, episode number 326. Stop reinventing the wheel, use Dapr instead. Welcome to DevOps Paradox. This is a podcast about random stuff in which we, Darren and Victor, pretend we know what we're talking about. Most of the time, we mask our ignorance by putting the word DevOps everywhere we can and mix it with random buzzwords like Kubernetes, serverless, CI/CD, team productivity, islands of happiness, and other fancy expressions that make us sound like we know what we're doing. Occasionally, we invite guests who do know something, but we do not do that often since they might make us look incompetent. The truth is out there, and there is no way we are going to find it. P.S. It's Darren reading this text and feeling embarrassed that Victor made me do it. Here are your hosts, Darren Pope and Victor Fussell. Victor, how many years have you dealt with microservices, do you think?
I don't know. I'm too old to count anymore. I don't know. 20, 50, I don't know, 100. I don't know, man.
You're getting to my numbers now. No, it's not 100. At least I hope not. Could you argue that the first mainframe was a microservice? I think you could.
I mean, the mainframe, I haven't worked much with mainframe, but from my perspective, our personal experience, the first microservices was Linux. I know that nobody thinks of it as microservices, but I do. Kind of, yeah. Small applications pipe to each other, to combine them to accomplish something. Yeah.
On today's show, we have Mark Fussell on with us from Diagrid and one of the co-founders of Dapr. Mark, how are you doing today?
I'm doing fantastic. It's incredible to be here today.
What do you think? Do you think the original mainframe was just a big microservice?
Well, it had networking. So yeah, I mean, if you network things together and join them together, then they have microservices between them. I mean, microservices stem from a business need. It was a desire for businesses to ship things a little faster than before. So rather than you waiting for this great big compiled thing to work together, you split things apart. So team A could do things independent to team B. So yeah, if you split them apart, maybe a mainframe is a microservice split apart on different terminals.
So what you're telling me is that Dapr was greatly influenced by the mainframe. That's what I'm hearing.
Yes, it was. Yes. Yeah, there we were on a terminal one day thinking, wow, how do we turn this thing into a microservice? Well, yes and no. I mean, in many ways, it was influenced by just the industry as a whole shifting towards distributed applications and hosting it on multiple machines as well. So the trend inside the hosting environment, along with the need to ship fast, was the driving factor for Dapr.
So for anybody that's not familiar, easy for me to say, with Dapr, and that's DAPR, what is Dapr? Why did it come into existence? Why did it need to exist?
What was happening is that we saw all these teams, and particularly not only in Microsoft, which is where we created the thing and started the initial incubation of the project, but also outside of it when we dealt with hundreds of enterprises, building the same old technology again and again. And that really was, how do I discover other services and talk between them? How do I send messages between them for these event-driven applications? How is it that I coordinate across them all? And particularly, how do I plug in different types of, say, storage or backing secret stores and things like this? So it came from this need of looking at distributed systems patterns, common patterns that you see that people build time and time again, and saying, hey, stop reinventing the pattern. That's a bad idea. Why don't we take those patterns and codify them for you and give you a great set of APIs that you can put into your applications and build, and then deploy it onto any one of these platforms. Of course, in the early days, there used to be lots of distributed systems platforms. There was a Docker Compose and Mesosphere, of course. Mostly it's Kubernetes now. So it was born of the idea of, let's help you stop reinventing the wheel, reinventing the pattern, put those into a set of APIs and give it to you developers so you can build applications faster on these distributed systems.
You're answering that with reinventing the wheel a few times. You kept saying that.
Yes.
But didn't you just reinvent the wheel by doing this?
Well, yeah, I mean, we've reinvented the wheel, but it's stopping everyone in reinventing their own wheel. So rather than everyone having their own wheel and I'm building my own wheel from scratch, you go buy a wheel. So this is buy a wheel, not build a wheel.
Okay.
Yes, and so that's what it came down to. And so what we saw is let's just take a common example. Because you've distributed your application and you've got team A who's building sort of let's just say an order processing service and another team B that's doing their payment service, and they're working together, and you want to build and deploy these into different environments, you've got to be able to find and discover those services. And it gets very painful when you're a developer there saying, oh, I have to open HTTP ports, I have to open up ports and kind of find networking and configure all that stuff. Why can't I just say there's a thing over there called application B and I can just call a method on it? So all of that abstraction of discovery, calling another service, retries, security, and all of that was basically taken care of for you for one of its APIs, as an example. And so that's what we call service invocation and service discovery.
I think one thing we have to come up with, at least in tech, we have to come up with another example than order and payments. That's just boring. Come up with something else. Okay. I don't know what it is.
Shopping cart.
Yeah.
Okay.
Yes.
So you reinvented the wheel. You agree with that, which is fine because, we're joking, not joking. You did reinvent it, but so that people didn't have to build it from scratch, because usually in places they already had a message bus. They already had other orchestration tools, meshes, whatever. But they were having to wire it up as a bespoke solution for themselves.
It was that, yeah. But Dapr took this thing to another level as well, because it wasn't just providing the APIs for how you do that communication, but it also provided a connection and an abstraction over the underlying infrastructure that they talk to for that API. So let's take a really good example. Say you are using the Dapr PubSub API, where you want to publish messages and receive messages. Super common scenario. So first off, a very common scenario of I just want to simply have these applications receive messages on some event that happens, and I want these other applications to publish them. You typically go and build go and find some sort of message broker. So you go out there and you say, oh, we're going to use Kafka. Kafka's the thing we're going to use. And someone knows, well, why Kafka? And that's just because I heard about it last week. And so they start building against this all and start using it all. And before you know it, you've sort of tightly bound. Well, first you've had to build the abstraction called PubSub on top of Kafka because it doesn't exist. So you have to build all of that. And then you've tightly bound Kafka into all your code. And then 6 months down the line, you find that the platform you want to move your code to or your choice of design changes. And so now you have to rip out all this code around Kafka and put it all in your other message broker. So Dapr came up with this idea of a component model where you can simply say, keep your API, don't change your code. But if you want to switch the underlying message broker from Kafka to, say, AWS SNS or to another cloud provider's message bus or RabbitMQ or MQTT, you can just switch that around and your code doesn't change. So this gives you cloud portability and, importantly, a local development experience that I can then take to a cloud. So that combination of the two of don't reinvent the same API and will connect you to your underlying infrastructure without you changing your API became very powerful.
How often do companies even think about those things? Kafka. In my head, it's usually kind of, you realize that once you decide to switch from Kafka, not before you are started implementing Kafka, right?
You'll be surprised how often it happens. So let's give you an example. We worked with FICO and they started using Kafka and they got to some scale limit and they decided they didn't like it. And so they started to re-engineer everything that they were building on top of Apache Pulsar. And in doing so, they wanted to provide a choice between the two anyway. So we saw that happen with FICO, who's a big payment provider. We often see people as well who might build against, say, something like Kafka, and then they moved and told that they're going to move to AWS and deploy everything there. And though AWS has a managed Kafka, they often start to use SNS as an alternative around these things. Or actually more another way around is often they start using SNS on AWS and then they want to switch to a Kafka, the managed Kafka service, the MSK. And so you get those switches. So it happens a lot. And also when they want to kind of switch between platforms. So we see it quite regularly actually. And the code you have to rip all out. is a huge effort inside the team. So it falls into a platform engineering play more than anything. Dapr becomes a very clean contract between the application platform team and the developers above it all, either with an API or because you can plug in these different components underneath it all.
So I'm thinking about Dapr. You said it came out of Microsoft. How did they let it out?
well, that's right. Kind of many ways we let it out. I mean, we were.
Was it kind of like you put it on USB stick and then you went out to resign from Microsoft?
No. From the very beginning, we were lucky to be in a team called the incubations team, which was part of Azure. It was actually in Mark Razanovich's org, who's the CTO of Azure. And we said right from the very beginning, we wanted to release an open source project. In fact, it was very conscious right from the beginning that it wasn't even in a Microsoft repo. It was in its own repo. So the project had very clear goals to begin with. Implement common APIs, make sure you have great abstractions of infrastructure, make sure an open source project. And so after it got released, within a year, we actually donated it into the Cloud Native Computing Foundation. They accepted it straight in as an incubation project because it took off so well. And it's lived there ever since. And it's had been a great home. And it's matured very, very well inside CNCF, and CNCF has helped it grow into a huge community today with thousands of developers and thousands of companies using it. So, we track over 30 to 40,000 companies who are actively engaged with using Dapr today. And we have a big community of 9,000 developers on Discord that actively engage and build and contribute to the project. So, it's done well inside the CNCF.
Where's it landed in its cycle? I mean, if it's incubating, or it came in obviously in incubating, where's it at right now?
Well, last year in October, it became a graduated project inside CNCF. And we actually were the first project, I should say, to go through the new process that CNCF had instigated, which was quite rigorous. And they interviewed a lot of end users and a lot of community members and made sure that the project is very healthy. So last October, it became a graduated project, which is sort of the highest level you can get to inside CNCF. I mean, there's about 25 other projects there today.
I think it's the key. You graduated.
Yes.
Yeah, you. So
Yay.
what's the postdoc for that? I mean, now that you graduated, it's...
Well, that's continue to grow the community and make sure that we add features and build things out. One of the biggest directions we've taken down in the last year or so is to implement particularly workflow as a workflow engine into Dapr, which is sort of a huge ask, and it's been a big endeavor, but it's finally there. And then building on top of workflow, we're building a lot of agentic applications on top of that and agentic frameworks. And that, I mean, the way I look at agentic applications is that they're just distributed systems with smarts and LLMs. And so now with a very code-first workflow engine, and when growing the community, we're seeing a big rise with Dapr being used for building agentic systems as well.
So this is interesting because until this moment, I haven't been asking questions because I know Dapr. I don't know what to ask. And now you're saying agentic and workflows. That's completely new to me. Kind of, what are the workflows?
Oh, so Dapr has a code-first workflow engine. So if you're familiar with the workflow engine, it allows you to run durable state and durable execution. So yes, durable execution. I run and write a piece of code. I write business logic. Take a state machine. It's a state machine with 5 steps, 10 steps, 100 steps. And I want to make sure that if it fails at any time, it recovers its state and continue where it left off. I don't want to be going back to my order processing system and re-kicking off my order again. So workflow engines today have played a crucial role in business logic all the time. What's key about Dapr's one is it's a developer-friendly one. So it's in 5 languages. You can write it in code, and that allows you to write effectively durable execution. And based upon that, you can build, of course, agentic systems.
I want to go back to the Microsoft days. I'm sorry, I keep bringing this up.
Okay.
How critical was Dapr to Azure? You said it was under Mark's organization. It just seems like, again, I goes back. Why let it out? Of course, the same thing could be said of Kubernetes, of letting it out of Google. But
well, I mean, it was very much about if you let these things out and have a life of their own, they become broader than just within inside any organization. So I think any organization, if it wants to hold on to its technology, it can, but it never becomes as widely adopted as if it becomes community adopted. And Kubernetes is the perfect example. Yes, Kubernetes would never have taken off if Google had held onto it. By releasing it, it became a growth thing within inside the community as a whole. So that was the entire philosophy with Dapr. Microsoft wanted to release a runtime that enabled you to host and run code across any systems, and they didn't need to hold on to it themselves.
But wasn't that what .NET was supposed to be for? Sorry.
Well, yes, but then if you look at .NET, it's only .NET. It's only a .NET language. Dapr spans all the multiple languages. So we have Java, .NET, C#, Go, JavaScript, Python, and so it became a multi-language runtime. And that's another thing that made it key. Today, we see lots of different organizations that have many different languages when they build things. In fact, increasingly, the amount of Python that comes into the code that goes alongside your Java code, we see that all the time. Take my Java application, stick Python in that, and Dapr helps bridge that as well.
So how does that work? I'm curious. When you have SDKs in different languages, is it that you're writing everything in one language and then you have some kind of engine that, when you push it to the main branch, it transforms that to all other SDKs? Or you're maintaining each SDK separately in a way?
We're maintaining each SDK, but that's where the APIs come underneath the covers. Dapr exposes HTTP and gRPC as its core APIs. So if we go back to PubSub, it has an API for PubSub. There's an API for the service discovery and service calling. There's an API to get secrets. And that's just an HTTP API or a gRPC API. So you can do that. And in languages that are very HTTP friendly, like JavaScript, that layer of the JavaScript SDK is very, very thin. But when you get to something like Java as a language, which is very type heavy and things like this, giving a great experience. And so, in the Java world, Dapr integrates really well with Spring Boot and the Spring framework. And then it takes hold of that. And, there's a Java SDK that translates down to these underlying APIs. And we did the same with .NET. Inside .NET, there's ASP.NET Core as the great framework and runtime for hosting it. It integrates well with the .NET SDK, and that in turn fits in with the Dapr APIs. And so, yes, they're very little handcrafted, but underneath the covers, it's just HTTP that you're using.
Well, it's always a TCP call of some sort or another.
Yeah, or it's a TCP call, yes.
It's a TCP. It all boils. And gRPC and HTTP still end up being the TCP call.
Yes, okay, ultimately, yeah.
I won't poke on the Microsoft thing anymore, at least I'll try not to. It was just, but you got to give it to me, right? It's like, okay, coming out of Microsoft, it seemed like, let's .NET all the things, and then all of a sudden we have something different, which is cool and great. I don't have a problem with it. In fact, I'm not a .NET developer. I am proud to say I have never programmed with a Microsoft language in my career.
I did. Yeah. I worked with .NET. And then in one of my jobs, I was forced to work in Java, and that was suffering.
Yeah.
Back in the day, just to be clear, back in the day, things changed. I think it's the other way around afterwards, but yeah, it was good.
Okay, Mark, Magic Hand Wave. Dapr is being introduced into an organization. Somebody went to a lunch and learn, somebody went to a meetup, saw Dapr. I was like, hey, that would be a great use case for X within our company. We're getting ready to refactor this thing, or we're getting ready to greenfield this thing. What are those things? What's a good first hello world type thing that you see Dapr used for a lot?
Yeah, so the first thing that we see, there's a great case study on this. Actually, if you go to the CNCF Dapr case studies, there's a great case study there from Data Galaxy. And if we take them as an example, they had a large monolith application. It was all bound together by compiled code. And they really wanted to be able to separate out a separate process or a separate thing that did a whole bunch of translation of documentation that they had. And so what they did is they wanted to effectively modernize their monolith, as it were, by building a separate piece of code rather than compiling it all into the same thing again. They had a separate team who could build this translation app, which received messages. So all the actual documents that got received were put into a state store, and then a trigger message was sent to this other translation process. It loaded up the documents from the state store, did all the translation, wrote them all back, and then sent a message back to sort of the original, let's say, monolithic application and triggered it all and said, it's all done. And so now they can separate this whole new piece of business logic of translation and basically analyzing those documents and sort of augment it to their existing application using messaging as a way of coordinating what it was done. Yes. So they basically integrated and started to build an event-driven application that was attached to their existing application. So we see PubSub a lot become sort of the additional add-on or the way you start to break your application apart, whether you're just adding on like Data Galaxy did to theirs, or whether you're sort of actually taking the original application and sort of breaking it apart. So that's kind of one very clear case. Another one that we sort of run into a lot is just, I think, workflow, I would say, going back to that. And that is a lot of people have some handcrafted, ugly piece of code with lots and lots of if and else statements and all sorts of retry logic and things that they've sort of tried to get together over the years. And it's just so hard for them to kind of understand what this code is doing. And so we've seen a lot of people sort of refactor their original code into a very clean Dapr workflow engine that gives you this reliable, durable execution of state machines. And so they can segregate it into these different activities, and it becomes very clean, reduced code, very clear to understand, and also very reliable code. So those are kind of two very clear scenarios of using workflow to improve the reliability, make it more readable, and sort of reduce the complexity of your code, make it more manageable. PubSub for communication and modernizing existing applications or adding new business processes to things. So hopefully that gives you some ideas around this. But there are many like this. We can go into secrets as well. We see secrets API gets used a lot where people have had to go and pull some secrets from some secret store and manage it all. And they have a little process that does that, and they share this process around. And instead they could use a secrets API to say, pull a secret from HashiCorp Vault or Azure Key Vault or one of these ones. So that's another one as well.
How much kind of that overlaps with some Kubernetes features? Like, for example, you just talked about secrets, right? If I would not know about Dapr, I would say, hey, that's why we have external secrets operator, right? You write 7 lines of YAML and your secret is there, whatever it is. It's mounted. Or like communication between applications, right? We have Kubernetes secret service. So how much there is a conflict of sorts? Not a conflict, but overlap.
Well, Kubernetes is an infrastructure play. It's not an application play. So you can, in that secrets management, yes, the secrets API in Dapr can store and load secrets into a secrets store in terms of Kubernetes it does. But most organizations don't want to keep their secrets that they have inside a Kubernetes secret store. They want to keep it inside a cloud service like Azure Key Vault or AWS Secret Service or GCP. So they keep all their secrets there. That's what they want to do because they can centrally maintain them and manage them all. So, and that's the beauty of Dapr. If you use the secrets API one moment, you can point to that Kubernetes secret store and pull from there. But if now you've changed and said, no, all my secrets or have to be stored inside a secure vault that's a cloud service, doesn't change your code. You just change that component, point to another one, and off you go. So the answer is it takes advantage of those where possible.
Okay, now I get it. So I misunderstood initially. Yeah. Basically, if I have my secrets somewhere in Vault or wherever that is, unlike external secrets operator that pulls it into Kubernetes secret, you're pulling it directly to the code?
Yes, into the application. Okay. So, I mean, what's the example here? Yeah.
You're skipping basically Kubernetes secrets as intermediary.
Yes. Well, I mean, you can use a Kubernetes secret as a store, but you can use other stores as well. And I mean, and the scenario here is I'm using a secret because, say, I want to pull a secret to talk to a database. Yes. And I have to get that secret from somewhere. And so the secrets API in Dapr allows you to retrieve that in a consistent way, wherever you choose to keep your secrets.
Yeah. As opposed to pulling it as a Kubernetes secret from Vault and then mounting it. So you're skipping the mount.
Yes. Exactly. So that's that's one of the benefits is adaptability of code. And you see a lot of this time, I can adapt my code, I can make my cloud code agnostic. And so it's all about the application developer, about what it does. And, going back to your example as well of, how is it I call between two applications on Kubernetes? Well, Dapr has this amazing concept of identity. So when you spin up a piece of code in a process, it gives it identity. It gives it, here's code for application 1 and here's code for application 2. And application 1 can call application 2 and its methods on it because it knows how to identify them. And so that name discovery, that identity gives you very powerful security at the application level, not only in terms of discovery and the ability to do MTLS code between them all, but you can say application 2 can only be talked to by application 1 and no one else can talk to me. So you get these bounded security contexts that make it really powerful at the application level. So application level identity.
It's essentially replacement of Istio, for example, right?
Yes, but Istio doesn't do anything at the application level. Yeah, so yes, you're right. Istio does everything at the network level for routing, but Istio has no concept of saying application A and application B. It just knows about network traffic. That's it, and how it all goes.
Yeah, I mean, it knows, doesn't know application. It knows container.
Yes, it just knows container.
The same.
Well, not really, because application identity is the key. The actual piece of code has a named identity, and that identity is given a spiffy identity. And so you can actually say, it's a bit like, you're Victor and I'm Mark. It's not just, your person, I actually know how to call you and find you and send something to you. Yes, Victor, here's my message. Not just like there's some container somewhere that I have to send something to. And so the process identity with a spiffy ID and how I know how to discover and call something is a very powerful concept that you can't get at service mesh levels.
Let's keep writing that one out for just a second, because if Victor is offline for whatever reason and you send him a message, what happens? Do you just keep retrying until you've decided that you're not going to retry anymore? That he's unfriended you, I guess, is what I'm looking for.
Well, Dapr does have, and this is one of its great things, it does have these things called resiliency policies. So, if it has the ability on any of its APIs to say retry X number of times before you give up, or it has things where if you call something and it isn't there, you can do a circuit breaker, and you can just say, that's not failing, let's do a circuit breaker, let's stop, let me retry again a certain period of time and sort of bring that back in. So the concepts of timeouts, retries, and circuit breakers is fundamental to every Dapr API. And this is the thing that every developer has to then start to build themselves. And so Dapr gives you these cross-cutting concerns. Not only does it give you the fundamentals of reliability, but it gives you the fundamentals of traceability. When I trace my calls all the way through my application calls and how it runs, whether it's a pub sub message or a call to another service for service invocation or call to a secret, you get end-to-end traceability, all sent out as open telemetry messages that can be sent to any of your telemetry stores. So you can now see this beautiful graph of your application calls. You have resiliency built in, and going back to this identity thing, you actually have security boundaries. So this is the thing that application developers always run into. It's easy to get something going, but it's hard to deal with failures. It's hard to deal with security. And invariably, the observability and telemetry is always left as an afterthought. And without that, you're actually flying blind in production. So when you see this on the application level and get this for free, that's the power of Dapr.
So you're all in on OpenTelemetry.
Oh, totally. Love it. OpenTelemetry is fantastic because now all the events that happen in your application, like save this secret or send this message or run this workflow, are all sent as OpenTelemetry messages. I mean, we adopted OpenTelemetry way back, right at the very beginning. We also adopted cloud events as well as another standard. So we're all about adopting standards. Cloud events was a very early adoption for how you shape the messages. OpenTelemetry we adopted as even before it became a V1 and baked that deep into Dapr. Spiffy for identity management for applications, particularly also making sure you integrate with other systems like Cert Manager and other standards around this. We opened also the standard trace header tracing, so W3C trace event and how tracing happens in cross headers. Yeah, we adopted that. So very much about adopting standards and going with where application developers expect the standards to become important to them.
This sounds almost too good to be true.
Well, it is true. And that's why it's such a highly used project. I mean, we have a huge growing community around these things. And, the continued adoption of Dapr is that I think what we find is that when people discover Dapr, not only does it, the challenge you get is that people like to write these things themselves. Yes, they like, well, I can build that sort of thing like Dapr, and the answer is always you can, but the breadth of it will take you a long time to do that. By adopting Dapr, you actually sort of not only reduce your code, but you actually reduce your time to getting your into production. And we've shown this through numerous case studies that if you use Dapr, you could probably get your application into production with a very mature piece of code now in about 30 to 50% faster than you would do normally. And it's very adoptable from a brownfield perspective. It's not about greenfield. Going back to that case study I talked about with Data Galaxy, adopting on existing systems as well as new ones. So yes, it is too good to be true. And that's why the project is an amazing one to become part of.
We are against CV-driven development around here, so that's fine. We don't want people recreating everything. So it's interesting you're saying if I use Dapr, and I'm going to misuse your words probably against you, I can speed up something 30 to 50% to actually get running on metal.
Or to getting it into production. It's just
getting into production.
Yeah, going back to the don't reinvent the pattern again. Don't reinvent the wheel. Just don't have to spend hours like understanding a Kafka library. I mean, let's just take an example. Someone adopts Kafka. Oh, I'm going to use Kafka for an event-driven system. So first off, going back to my earlier sample, Kafka doesn't have the concept of pub/sub built into it all. So there you go. You've got 2 months of development time to build a pub/sub abstraction on top of that and to think about it and then how it all works on top of your learning for how does Kafka actually work. Instead, Dapr is a component that not only has all the best practices for using the Dapr SDK that's been refined now from thousands of companies using it all, but also it has built in the right abstractions and semantics for pub/sub messaging. And you can use all of that and run it at scale, and it's used by many, many large organizations. So you get all the benefits of Kafka, but the ease of development and less code to maintain, and you get to production. And say you don't like Kafka all of a sudden, you could switch it out without having to rip out all that Kafka code and change it to Azure Service Bus or GCP pub/sub. And there you go. That's safe. So you save maintenance time, less code, and you build on the best practices of other developers who've contributed to the code base.
If you ignore Dapr for a second, why would somebody choose Kafka for pub/sub if pub/sub does not exist in Kafka?
Well, it's more of a case of building the publish and subscribe semantics inside there, yes? So in other words, I just want to be able to subscribe to topics. So it's not that Kafka can't send messages, it does.
I mean, kind of like if there are plenty of other solutions, like if you use nuts, that doesn't matter now whether it's better or not. It's baked in. Kind of, why the heck did you choose Kafka? As a company, kind of...
Yeah, well, I mean, that's just, I mean, exactly. Well, that's probably because someone chose that. All I'm saying is like some person might have just used Kafka before and then they started wanting to build these things on top of it all. So we often just see people choose decisions because they heard about it before and things like this.
Well, okay, let me ask this question because we've thrown out Kafka, RabbitMQ, all the other things, all these underlying things that can be tied into. But I don't want to have to stand that up to actually do my development. What is there something baked into Dapr that I can use? Just that might be even good for POC, maybe for even QA. I don't need the big heavy lifts of everything else.
Yeah. So that's exactly where this component swapping comes in. So when you install Dapr on your local machine, so you download the Dapr CLI. That's a simple, little download on your machine. You run a Dapr init command, and it sets up a local development environment on your machine. And on your local machine, it deploys Redis as a container running on your local machine. And it uses Redis for pub/sub and Redis for that messaging. So you now as a developer automatically get Redis for all pub/sub messaging and using against those APIs out of the box, ready to go, and you develop against it all. And so for your local development, you're using Redis. And then when you decide that you want to deploy into production, you then just swap out that Redis component for Kafka and off you go.
Which you wouldn't use Kafka, but that's fine.
Yeah, we wouldn't use Kafka. You'd use, exactly. You'd use, one of the cloud providers.
You could use Redis, right? You could use a hosted Redis if you wanted to keep it as A to A as you can. You
can, yes. And in fact, we see Redis a hosted Redis solution used all the time for messaging. So let's just say, Kafka maybe was a bad example for PubSub. People using, maybe it was a very bad example.
Well, RabbitMQ. We could say
RabbitMQ. RabbitMQ. So let's just say, I'm using Redis, my local container for all my PubSub messaging, and then I go off and use RabbitMQ, and that's it. I'm done. And all I have to do is in my deployment pipeline, my code does not change. All it changes is that little component definition, and off I go.
So how do you crack the knuckles of the developer that wants to code to Redis instead of using the Dapr APIs?
Well, they can, but if they do, then they're sort of tying themselves into Redis, as it were, as an API, and they're locking themselves into that, and they're not getting the benefits of portability of their code, and they're having to write a lot of those abstractions themselves. Again, a PubSub API on Redis is still taking you some abstraction around all that. So, they can do it. Nothing preventing them doing that, but Dapr gives you all those other benefits I talked about: resiliency, security, telemetry, and you get all those cross-cutting concerns on top of using that. And so you'd have to build those all yourself.
So as a tech lead, as an engineering manager, I would tell my developers, look, do not write to the actual implementations. Stay at the API layer.
Correct.
Otherwise, we're going to have a conversation.
Yes. And this is why we've seen Dapr used enormously inside platform engineering teams, because now you've got this beautiful contract between what the platform engineering team has and what the application team wants. And we've seen this time and time again, where actually platform engineering as a whole slightly ignores the application developer. And the platform engineering team kind of goes, oh, we're giving you these message brokers, and that's what you have to use. And then the application team bakes in, say, RabbitMQ into their code, and they're forced to tightly couple those two together. In the case of Dapr, it provides a very clean API between the platform engineering team, which can control what they want to put in their platform, and the application team not having to change their code if decisions are made that a different message broker is going to be used and things like this. Nowadays, more than anything, we spend a lot of time with the teams that have built platforms using Dapr as that abstraction between the application teams and the platform engineering teams.
So if I can ship to production 30 to 50% faster by using Dapr, how much faster can I ship if I have AI writing all my Dapr code?
Well, that depends on your AI. That's what it's doing. I have no qualm. I'm not in any game to say to you what AI should be doing for you and things like this. And it probably is writing something that you should put in the code anyway. So, let's just be careful about what it's doing. But what Dapr has done is it's provided a API that abstracts away how you talk to different language models. So we introduced this API called a conversation API. And again, with this component model, you can plug in either OpenAI models or the Anthropic models or DeepSeek or Olam or wherever else you want. And so you provide a prompt and then it calls it down and hands it back to you, layering some additional features on top of it, like PI obfuscation and prompt caching and things like this. So you can swap out your underlying models without being tied to them and have that flexibility. So we did that for sort of prompt calling as an API, and then started to combine that, of course, into the Dapr agents framework to help you build agents that could also use those language models as well.
So what does that look like, building a Dapr agent or an agent driven by Dapr?
Well, going back to my earlier comment that, I firmly believe that all agentic systems are simply distributed applications with smarts, so it's being language models. What's actually gone and happened is that we've actually started to bring together the APIs that Dapr has, like messaging and service invocation, and particularly workflow, and put that into an easy to describe framework for you to build agents that are durable and reliable. So you can go up and create a new durable agent, and you can give it free properties, such as here's its state store to save its state into, here's its goals and its role, and here's the language models you want to talk to, a few lines of code, and you're off and running with an agent that effectively can use language models and tools to make decisions depending on what task you've set it. So a very easy to use, clean API that's currently in Python SDK. And that's where we're experimenting with it. And we're trying to get the Python SDK with Dapr agents to a 1.0 sometime later this year. So the agentic side of these things, building on all the experience we've had for building distributed systems like messaging between agents, for example, or durability to save their state. And going back to my workflow example, the fact that, if you think about an agent, it's a state machine. It's doing 20 different steps. And you don't want it at step 15 to die. And then it goes, well, I just can't remember what I just did. What was my memory? What was my state? What was I doing? Because a machine crashed. You want it to carry on. So the vast majority of frameworks today don't have that durability. Agentic frameworks today don't have that durability. And so that's where Dapr Agent shines, in having these long-running, durable agents that allow you to take advantage of the Dapr APIs for things like messaging as well.
What sort of systems, what sort of business problems is Dapr not suitable for?
Oh, good question. Well, I think in terms of any type of vertical industry, and I would say that if you're building on top of Kubernetes by far, you should use Dapr. No question about this. Dapr is used by every industry there is possible. So whether it's a healthcare or flight ticketing system or a trading application, I think Dapr is applicable to all of those. I think some of the places where Dapr still has work to do is in how it has its storage APIs. It has the ability to store state today in key value stores, but I think that making sure its state is stored inside and blob storage and NoSQL storage is something we're working on. So, I still think you generally have to kind of combine Dapr with, let's just say, database APIs still, if you're just retrieving and doing queries against them all. Dapr doesn't attempt to try and abstract databases in any way too much, other than sort of key value storage around these things. So I think that's one place it would evolve into. But to a large degree, for applications that you're running on Kubernetes, Dapr should be a de facto solution for everything.
What if you're not running on Kubernetes?
Well, you can still use Dapr. Dapr actually is platform agnostic. We actually have people who actually deploy it onto a set of VMs. You just got to do a little bit more work yourself in terms of how you manage the deployment across them all. Because in the Kubernetes world, clearly there's commands for you to deploy it, and it takes care of the distribution across multiple machines. You have plenty of people who just take Dapr and they deploy it on a VM and they manage it all themselves. But of course, that just means more work in terms of getting it there.
So with it being just a runtime,
yeah,
it can be done. It's just not going to be as fun, I guess.
Yeah, it's not as integrated. Yes, exactly. It's not as integrated with the hosting environment, and you'd have to use some pipeline deployment. You have to use some bash scripts or some scripts to deploy to every machine and manage it all yourself. Whereas Dapr has in the Kubernetes world a control plane, and it has a control plane anyway, but has a control plane that's integrated that gets deployed into a Kubernetes environment. And because Kubernetes has the ability to do multi-machine management in the sense of that, it has an easier integration with a Kubernetes operator and things like this.
Let me give you a magic wand.
Yes.
These are fun questions, right?
Yes.
If there was one thing about how organizations approach modernizing their stacks, what would be that one thing? Or maybe a couple of things. What do you think people are getting wrong? Especially in the light of Dapr existing and being graduated. It's not like it's new, put out by a couple of guys that were living in their grandmother's basement, right? This had money behind it to even come to light.
Yes. Well, I would say that, that's a tricky one because so much of this depends upon literally within inside the organization itself. I think that to a large degree, there is a lot of, let's just say, stasis where people get stuck in the system that they have, and there's a fear of change around these things. So more than anything, there is, how do I go about modernizing what this application looks like? There is a bit of a language dependency here thing as well. In the Java world, you get a lot of people who get stuck into Spring Boot, and I think Spring Boot is a very powerful thing there that influences that. And I would say also in the Microsoft world, .NET is a strong influence there in terms of how you should just use .NET around these things. And so I think a lot of people look into the language world only and say, look, I'm a Java person, so I can only use Spring Boot, and I'm a .NET person, so I can only use a .NET framework and that sort of things. And I think that's one thing that's you have to get past a little bit, because Dapr is sort of multi-language and crosses those boundaries around those things. I also I want to write this myself and enjoy kind of the technical challenge around those things. I think that happens a lot. I also think it's also making sure that you spend a bit of time with Dapr, and you've got to spend, like with any new technology, you're going to spend probably a good, let's just say, a couple of days with it, playing with it and understanding its power. But once you have that aha moment, you realize that it can just do so much for you and take away so much of the pain that you don't yet know about. For example, I think a lot of developers still underestimate the need for observability built into their frameworks, and they underestimate the resiliency that they have to build. And so I think there's a combination of like the developers who are more experienced realizing the problems they're going to run into. And I think if you haven't built a system from scratch all the way through before and then had to worry about the security, the resiliency, the observability, and dealing with the failures and all of that pain that it entails, you think it's an easy task when it's not in any way. And that's, I think, is the difference. So experience probably matters a lot as well in terms of what you've been through. And I think once you've seen that, played with Dapr for 2 days and crossed that aha moment, then you're not turning back. And that's what we see happen all the time. There tends to be the sort of more experienced developers in an organization pick up Dapr, push it through, and then you have a wave of other developers behind them.
It's because the experienced developers have built it all in the past that was not even half-baked.
Yes.
It's like, I don't want to do this again.
Exactly. Yes, I don't want to do this again. Why should I do this again? It's like saying to someone, why don't you build your own Kubernetes environment? Like, no one would think about doing that now. You know, why would I build my own distributed hosting system? Why I wouldn't do that. That would be a crazy thing to do. The way I like to describe it, the same thing that Kubernetes has done for hosting, Dapr is doing the same for application development. It took Kubernetes, 7 or 8 years or 9 years, they said 7 years to kind of cross the chasm, as it were, to kind of go from early adopters to mainstream. I think Dapr is kind of, with its graduation, things like that, is at this point now of crossing that chasm and going across to become much more mainstream in its usage. And I'd like to think in the next year, 2 years' time, it'll have crossed the chasm and it'll become, well, obviously you should do that, especially if we're building on top of Kubernetes. That's the sort of level we're getting. But I mean, if it took Kubernetes 7 to 8 years, I think it might take Dapr. It's been in existence for 6 years already. And I think it's going to take another couple of years as well to do that.
So 2 things I take from that. If you want to have CV-driven development, don't ever look at Dapr, because once you see it, you'll never go back.
Yeah.
And a variation of that is if you're stuck with the language, it's sort of like the Eagles Hotel California. You can never leave once you're into a framework. That's what it is. And that's that. And I think that's going to be the good thing. Like you were talking about Spring Boot and .NET framework. Once you're in there, you think you can't get out. Okay, you can, but it's going to be really hard. I think once you're into Dapr, though, I don't think you will want to leave.
No, that's true. Yes. And also we've worked very hard to make sure in the last couple of years to make Dapr bring it to the Spring Boot community. So, meeting people where they are and bring it into the .NET community. And so Dapr now has really good integration with Spring Boot and with testing frameworks inside there, particularly with test containers. The Java community uses test containers a lot, and Dapr is amazingly integrated with test containers in Java and Spring Boot now. We've done a lot to get Dapr integrated with Aspire for .NET World. So .NET Aspire is a thing inside there. I mean, .NET Aspire is a developer tool. Dapr is a runtime. So the combination of .NET Aspire as a developer tool and Dapr as a runtime is a great combination. So we're working on that still. And, in the Python and the other communities, we're bringing it to the runtimes inside those as well, which are a lot easier, really. And there's a lot less, let's just say, there's a lot less friction.
So Dapr existed. Why did Diagrid even come into existence?
Well, we realized that we wanted to kind of forge ahead with Dapr and actually take it to kind of a new level. And as you may have experienced, it kind of, it doesn't matter what you can achieve inside some large organizations. Sometimes you want to sort of forge your own direction and make sure that you can grow it into a very compelling business. And so Jeroen Schneider and myself, we decided to leave Microsoft and set up Diagrid because we saw this desire to build a platform play, think of it as a way of hosting and running Dapr, such that you can have an amazing experience, particularly building applications around workflow that allows you to build this durable execution workflow platform and run your applications there and have hosted Dapr endpoints. We call this product Catalyst. Think of it as like a server-like product, but you deploy Catalyst into your hosted environment. It has all the Dapr APIs available to you. And you can now go along and build your application against those APIs and run your code anywhere. So you're not just bound to Kubernetes. You can run it on a VM, you can run it on a function, you can run it on a container app, and yet use all the Dapr APIs as part of all that. And in particular, workflow is becoming key for running and building those applications. So that's where we built Dapr as a platform play, and it's getting great adoption and usage with inside organizations we work with, as well as us being contributors back to the project itself and continuing to be now Diagrid as the primary maintainers and contributors into the Dapr project. So we've kept our grassroots with inside Dapr itself and our contributions to the community.
So you're the primary contributors, but you're not the only contributors.
Correct. We're not the only contributors. No, there are plenty of other people who contribute from different organizations, whether that's NVIDIA or Amazon or Microsoft, of course, and many others who do inside all that. We've decided to invest heavily in making sure that we build a compelling technology and keep the project alive and going, and continue to innovate inside it all, particularly with workflow, and that's the durable execution side of these things, because that is a very powerful technology for building these business applications. And when you combine it with the Dapr communication, like pub sub and service invocation, we like to say that no workflow is an island. And so the combination of the Dapr's communication APIs with workflow, it makes it very compelling for organizations. So that's where we invested a lot of our engineering time. Other organizations invested in other things as part of Dapr as well.
So Dapr can be found at dapr.io, that's DAPR.io, and Diagrid is at diagrid.io, that's DIAGRID.io. All of Mark's information is going to be down in the episode description. Mark, thanks for being with us today.
Fantastic being here. Thank you for having me.
We hope this episode was helpful to you. If you want to discuss it or ask a question, please reach out to us. Our contact information and a link to the Slack workspace are at devopsparadox.com/contact. If you subscribe through Apple Podcast, be sure to leave us a review there. That helps other people discover this podcast. Go sign up right now at devopsparadox.com to receive an email whenever we drop the latest episode. Thank you for listening to DevOps Paradox.